Okay, dear students, let's see what is there in this question. A student throws a ball towards a wall. The ball is released from the point 1.8 meter above the ground and 8 meter from the wall. The diagram is clearly shown here. The initial velocity of the ball makes an angle 48 degrees with the horizontal. Air resistance is negligible. There is no drag force. The diagram shows the initial path of the ball and P is a point on the path. Draw on the diagram an arrow to show the velocity of the ball at the point P. Label this arrow V. So what is going to happen at this point P? So we have to first find in what direction is the body going and what is the velocity, in which direction is the velocity. So clearly, like, it's kind of obvious thing that there will be a tangent here, and this tangent will be given the symbol that is V, because it is written that you have to write V on it. So this is the velocity, and we have shown it. So you can even write there like it will be the tangent to the trajectory at the point P, and this is how it is shown. So this is the part A1. So we have done it. Let us now move to the next question and see what are they asking. Yeah, you see the mark scheme is also given here. Arrow tangent to the path is in the correct direction. So that we have already done. So the next part is the acceleration of the ball at the point P. Label the arrow as A. So now we want to show the acceleration. So the easiest method of finding the direction of the acceleration without any confusion is to think about the forces. So wherever is the net force which is acting on the body, the net acceleration will be in that direction. So this is a projectile motion. Projectile motion means that once the body leaves my hand, the only force which is acting on the body is the weight. That is the definition of a projectile motion. So I'm throwing this body. So once it is out of my hand, the only force should be weight. So of course here, the only force here becomes the weight. Yeah, and in the same direction, there will be the acceleration. F is equal to m into a. So we can say acceleration is F by m. So in our case, it is equal to acceleration due to gravity, and it will always be downward, whatever be the position. Over here, over here, over here, any position there, the acceleration will always be downwards. And what will be the velocity? The velocity will always be the tangent to the trajectory at any point. So here we are writing V, here we write A. That's it. This should be the answer. We have the mark scheme, and let us see what is the answer given by IB itself. So yes, exactly, this is the answer. This is how they have shown. Of course, it is obvious thing. Now the next question is, the ball takes 1.3 seconds to reach the wall. The initial speed of the ball is 9.2. So initial speed here, it is given as 9.2 meter per second. Angle is given as 48. Determine the height above the ground at which the ball is going to hit the wall. Now, as such, if I think it's kind of simple question, we just have a SWOT equation and we would be applying values there, but there are some nuances. So if you have some knowledge gaps in this topic, of course, there will be a problem now to solve it. I will try my best to explain you each and everything. Let's see. So this body is thrown like this. So we would be creating two components here. First of all, the velocity is 9.2. So this is 9.2 cos 48, and this is 9.2 sine 48. So this is the velocity in the upward direction, and we are only concerned with the vertical motion, that is the upward direction only. Why? Because you just want to find the height, which is vertical. So let us assume that the particle manages to go like this, and this is the point where it is hitting. So vertically from this point, it is going to attain a certain height like this, and then it is coming back. But let's say this is the point where it manages to come back, but it is still not going down. So the projectile motion is not complete. So we are only concerned with the vertical motion now. So we are going to apply the SWOT equation, which is S is equal to UT plus half AT square. In these cases, we got to have a sign convention. You cannot work without sign convention. You have to even show sign convention that you are using. So the upward direction will be taken positive, downward is taken negative. Sign convention is completely based on your whims and fancies, whatever you want to do. Like upward is positive, upward is negative, it is your choice. So I just choose this positive and negative. So let us do it. So what is the displacement of the body in the vertical direction? I am going to talk only about the initial position here, naming it as A, and the final position here, naming it as B. So I only concern myself with the point A and B. I'm not concerned with the highest point here because I'm not concerned with it. I'm only concerned with the initial and the final position. So what is the displacement here? The displacement is from A to B still. So it is just this height, like this height. And let us call it as H. And of course, because it is in the upward direction, this will be positive. Although the velocity of the ball now is coming down, it is negative, but for us the displacement is positive because it is still up. So the displacement is plus H. What about the U? U will be taken as this. And initial velocity was in the upward direction. We are only concerned with the initial velocity's direction. We don't care about what is the velocity of the ball now. We don't care that at the point B, actually the shadow is going downwards. We don't care about that. So this will be 9.2 sine 48 into T. T is the time, and the time is given as 1.3 second. So you can just note it as 1.3 second. Plus half. Gravity will be in the negative direction. It will be in the negative direction because it is always going to be downwards. So we can say it will be negative gravity. Anyways, we are going to use the calculator. So it will be negative 9.8 half gt square. So the time will be 1.3 whole square. This is the height h. So this is the height h here. Clear? So the equation is there in front of us. We have just plugged in our values correctly, incorporating the sign convention properly. Now we just find the value and we get the answer. So I'm not doing it. We will just see the mark scheme. Okay. Okay. So yes, there you are. This is the mark scheme here. So you can see, first of all, they found the velocity the way we did it. One moment, please. Yes. Let me show you my working also, and we will think about the solution also. Now you see, so the same thing we did, 9.2 sine 48, and we multiplied it with the time 1.3, and this is half gt square. Now there is a problem here. We forgot to include 1.8, but I was supposed to say that, but listen to this. Determine the height above the ground. Now the thing is that when I used this formula, we have just found this height. This is the height h that we managed to find because our journey started from the point A and it was going up to the point B. I told you this is the point B, this is the point A. So what is the total height of the ball when it is hitting the wall from the ground? It means that you have to add this 1.8 also. So whatever is this answer, you will add 1.8 to that and it will give you 2.4. So your total height that the body is attaining is 2.4 meter. This is how we do it, and be very careful. You see, I don't incorporate 1.8 in my equations, but usually books do it. Books write it like S is equal to S naught plus UT plus half AT square kind of thing. So they give you the initial position also, but I believe this instead, like, it confuses a bit. So the better thing is that we are not incorporating the initial position and we just find the value of H, and later, without forgetting, we would be adding the 1.8 distance into the answer. So this is how we do it. So let's go to the next question now, see if there is any other question. No, there is no question. So this is it for this question, people. And so this is how we do it. Okay, dear students, thanks for watching. All the best.